Hello. Uh, we are going to solve a optimization problem in this video, and we'll be looking at more in the next few videos as well. So here is the problem statement. Let's suppose that we have a walnut grower. He estimates from past records that if 20 trees are planted per acre, then each tree will average 60 pounds of nuts per year. For each additional tree planted per acre, the average yield per tree drops 2 pounds. How many more trees per acre should be planted to maximize the yield per acre, and what is the maximum yield? So this is the problem statement, and at this point I would ask you to pause and read this statement multiple times and make sure that you understand what is given in the problem and what is being asked from us. All right, so I hope that you have paused and read this statement a couple of times. So I guess the first paragraph is pretty clear. So notice that we are talking about maximizing the yield per acre. So from now on, let's just assume that we have just 1 acre of land, and we don't have to worry about how many acres anymore. So just we have 1 acre. So I'm not going to say the word per acre again and again and again. So let's just assume that we are talking about 1 acre. So if we are planting 20 trees, then the yield per tree is 60 pounds per year. Once again, since we are talking about per year, let's also just assume that we are talking about yield per year, and then not worry about say that again and again. So if we plant 20 trees, then we are getting we are getting 60 pounds of nuts for each tree, from each tree. Now the second, so this is pretty easy to understand. Now the second sentence right here, it says, in addition to the 20 trees, right? So for each additional tree planted, the average yield per tree drops 2 pounds. So this would be the key. Understanding this would be key to solving this problem. So notice that for every additional tree, the yield per tree drops 2 pounds. For every additional tree, the yield per tree drops 2 pounds. So what does that mean? Well, we have 20 trees. Let's say if we have one more tree, so 21 trees. So if we have one additional tree, then the yield per tree will drop by 2 pounds, which means that the yield per tree will be 58 pounds instead of 60 pounds. All right, so what if we plant 22 trees? That is, if we plant 2 additional trees, then for each of the additional trees, the yield is going to go down by 2 pounds. So for 2 additional trees, the yield is going to go down by 4 pounds. So if we plant 22 trees, then the yield per tree will be 56 pounds. So I hope you understand what is stated in this sentence. So the question here is also kind of, I think, clear, is, how many more trees, that is, how many additional trees in addition to the 20, how many additional trees should be planted to maximize the yield per acre, and what is the maximum yield? Okay, so to kind of clarify the second sentence, let me make some remarks. So if 20 trees are planted, then each tree will average 60 pounds of nuts per year. So a total yield of 60 times 20, or 1,200 pounds of nuts per year per acre. Right, so from each tree, the yield per tree is 20. So the yield per tree is 60. So for 20 trees, the yield would be 1,200. What if we plant 23 trees? Well, that means we are planting 3 additional trees. So then the yield per tree is going to drop by 6 pounds, right? So for each additional tree, the yield drops by 2 pounds. So for 3 additional trees, the yield is going to go down by 6 pounds per tree. So now each tree will average, instead of 60, now it drops down by 6 pounds. So each tree will average 54 pounds of nuts per year. So a yield of 54 times 23, which is 1,242 pounds of nuts per acre per year. Now, what if I have 30 trees? Well, then I have 10 additional trees, and for each additional tree, the yield per tree goes down by 2 pounds. So for 10 additional trees, the yield is going to go down by 20 pounds. So if we plant 30 trees, then the yield per tree will be 40 pounds. So then we get a total yield of 40 times 30, which is 1,200 pounds of nuts per acre per year. So this is how much, if we plant 30 trees, we get 1,200 pounds of nuts per acre per year. So if okay, so that's going out of the screen. So let me show it this way. So now if we plant 20 plus X trees, that is, we are planting X additional trees, then the yield per tree is going to go down by 2x. So for every additional tree, it goes down by 2 pounds. So for X trees, the yield per tree is going to go down by 2x pounds. So if we are planting 20 plus X trees, then each tree will average 60 minus 2x pounds of nuts per year. And so a yield of 60 minus 2x times 20 plus X pounds of nuts per acre per year. Okay, so here's the problem statement again. So if X is the number of additional trees planted per acre, then 60 minus 2x would be the would be the pounds of nuts per tree on average. And so this is the yield per tree. And 20 plus x is the number of trees per acre. And in this case, the yield would be, let's denote that by y of x. The yield would be the yield per tree multiplied by the number of trees. So it's going to be 60 minus 2x times 20 plus x. All right, so now we need to do some reality check. That is, what reality check am I going to do? Well, the question now is, we have this yield function, and we want to know we want to find the maximum value of the yield function, right? So that is, how many more trees should we plant to get the maximum yield? Well, we need to know what are the possible values of x. So what's the domain of this function? So we need to come up with the domain of this function, because the maximum depends on the domain. Well, clearly, since x is the number of additional trees, x cannot be negative. So clearly x is a non-negative number. On the other hand, notice that 60 minus 2x, that's the pounds of nuts per year on per tree on average. So this is the yield per tree. So the yield per tree cannot be negative either, right? But notice that when x is 30, we're going to get 0 from here. And if x is bigger than 30, then this quantity would be negative. So 60 minus 2x would be negative when x is bigger than 30. So then we're gonna get negative yield, but that's not possible. So that means x couldn't be bigger than 30. So we have this. We want to maximize this yield function, and clearly x has to be non-negative. And we also said that the yield per tree must be non-negative as well. So, but this inequality here tells us that x must be less than 30. So x must be between 0 and 30. So now we know the domain of the yield function. All right, so now we need to find the maximum value of y on this interval from 0 to 30, and we know exactly what to do. We need to find the derivative of the function and the critical points. So y of x is, if we multiply out here, we get 1200 minus 20x minus 2x squared. So now the derivative is going to be 20 minus 4x, and that's 0 when x is 5. So clearly this derivative is equal to 0 when x would be 5. Now, so that's the only critical point. So so in this interval from 0 to 30, we have exactly one critical point. And if I apply the second derivative is negative, so second derivative of y with respect to x would be negative 4, which is always negative no matter what x is. So y double prime at 5 is also negative, and so the function is concave down at the point 5, and so it has a local maximum at 5. But there being only one critical point, that's got to be the absolute maximum. And you can check that clearly the maximum doesn't occur at 0 or 30, because we know when x is 0 or 30, the yield would be 1200, which is not the maximum clearly. So we see that we must plant 5 additional trees per acre for a total of 25 trees for a maximum yield of 1,250 pounds per acre. Okay, so this is it. We solved the problem here of of maximizing the walnut yield. All right, so I would like you to keep looking at this problem again and again and make sure that you understand the steps. All right, I'll see you in the next video with some more optimization problems.